here we're going to look at the mass spring system and we're going to come up with the equation for it. So if you're going to have a block, okay, which is having a mass m, we're definitely going to have a gravitational force mg that's acting downwards, right? And if you're having a spring on top of it, we're going to have KL, which you have already learned, where K is the spring constant and length L is the extension that is being produced. So that is the spring force which would act upwards for us. If you just do a simple force balance, we'll get KL minus mg is equal to 0 for a static condition. And that's pretty much the simplest equation which you can come up with. In other words, we can just say, but if it's moving, right? Let's say it's not in a static position. So we're going to have mass into acceleration to be a force, and the acceleration is just the second derivative of position, right? So we'll have my double prime of t when the change in position is given by y, okay? And this is actually the force with respect to time that we are looking at. And we have also learned some advanced topics when the spring is being damped. So over there, we'll have a damping force. Let's say it's given by Fd as the damping constant gamma times y prime of t. The velocity times the damping constant would give us the force. And hence a spring force in this case for extension of y, let's say meters or centimeters, would just be minus k into L plus y. Oh, sorry, if you're looking at the directions, then that would also have another symbol, because damping also goes that way, right? So c times y prime. When we are having all of this, we can do force balance again, and we can say that the mass into g is due to gravity, but if you are having a completely change in position which is due to an external force that is being applied, then we don't have the gravitation acting anymore, right? We'll be just changing the force term with my double prime of t becomes m times y double prime, right? So if that is being positive, so I'm taking this way as positive, so I would get an my double prime of t, right? So after being pulled, I'm saying it's at a static position. So my damping force would come to the other side now. It's plus gamma times y prime of t. And my spring force was also on the other side, which along with the, it's basically f of t plus f of damping plus my spring and my spring force was going to be my double prime, right? Yeah, so I'm bringing everything to the same side. Plus gamma y prime of t plus k y of t. That's the extension that's produced, right? So that is going to be the sum of all the forces that was involved. And in this case, it is the external force that I have applied on that direction, right? That was f of t as I defined it. That is my spring equation with all the terms on it. So if we do not have damping, we can of course remove this term, and then it will become much more easier. And if there was no external force being applied, then I can just remove f of t, which would make the equation much simpler.